Question number 27. Figure shows particle A and B of mass 3 and 4 kgs respectively attached to the ends of a light inextensible string that passes over a smooth pulley. Pulley is fixed at the top of a plane which is inclined at an angle of 30 degrees to the horizontal. A hangs freely below the pulley and B is on the inclined plane. The string is taut and the section of the string between B and the pulley is parallel to the line of the greatest slope. Given that the plane is rough and the particles are in limiting equilibrium, find the coefficient of friction between B and the plane B. Okay, so this isn't directly related to work, power, energy yet, but let's just solve it anyway. This is from the previous chapter, connected particles. Okay, the weight here is going to be 40 newtons. The force here is going to be tension, and here we'll have the the sine component of the weight, mg sine theta. And since this weight is bigger, the direction of motion would be this, meaning that the friction would be backwards here. Mu times r is the friction. This would be the cos component of the weight, mg cos theta, and this would be r, the normal contact force. Okay, so for part A, equation at particle A would be T is equals to 40 because the system is in equilibrium. And the equation at particle B is going to be T is equals to mg sine theta plus mu r. Okay, T is 40 is equals to m is 3 times 10 times sine 30 plus mu is what we have to find, and r is the force opposite to mg cos theta, so they're equal. Mg cos 30. Okay, now make mu the subject, and once you're done, you should get 5 under root 3 upon 9, exact answer, and rounded to 3 significant figures 0.962. Okay. For part B, it says it is given instead that the pulley is smooth and the particles are released from rest when the difference in vertical height is 1 meters. Okay, so initially we can see in the lower figure that the distance between their vertical height is 1. Use an energy method. That means we have to use work done by driving force plus energy loss is equals to work done by resisting force plus energy gain formula. Okay, use an energy method to find the speed of the particle at the instant when the particles are at the same horizontal level. Okay, so for the particles to come at the same horizontal level, this will come slightly downwards. It's over here, and this will move slightly upwards till it's at the same level as the other particle here. Okay, we need the speed of the particles at this level. Okay, so we know that this length plus this vertical length would be equals to 1. And this length is actually d. So d, which is the distance covered by particle A from here to here. And this would be d as well. That would make this length d sine 30. And d plus d sine 30 is equals to 1. This will give us the value of d, which comes out to be 2 by 3. Okay, now we use the energy formula, work done by driving force plus energy loss is equals to work done by resisting force plus energy gain. Okay, there's no power or driving force in this question, so this is 0. And energy loss would be equals to, again, there's no resistance in the question, no friction, etc. So energy loss is equals to energy gain. Okay, now looking at particle A, as it comes down, it loses its potential energy. So the loss in energy is the potential energy at A. Okay. Its kinetic energy would increase, so that won't be counted here. That's going to be counted at the other side. So kinetic energy of A is increases. Okay. Plus, looking at B, At B, the potential energy is also increasing because it's going up, its height is increasing. So potential energy of B also increases, plus kinetic energy of B is also increasing because initially the particle was at rest and as it goes up, it accelerates. So kinetic energy of B is also part of energy gain. So there's one energy loss, which is the potential energy at A, and three energy gains, the kinetic energy at A, the kinetic energy at B, and the potential energy at B. Okay, now let's substitute the formulas here. Okay, potential energy at A would be mgh. M is 4, G is 10, and H is D, the distance difference in vertical height, which was 2 by 3, is equals to kinetic energy at A. So, or kinetic energy's difference at two levels of A. Okay, so initially the kinetic energy was zero here because the speed is zero, and then the speed increases as the height drops. So the formula will be half times m common times bigger speed square minus smaller speed square, plus for B, the potential energy gain would be m times g times increase in height, which was d sine 30. So d was 2 by 3 sine 30, plus kinetic energy increase at B. So it's also was initially zero, the speed, and then it becomes some value B. So we're going to do half and m common times bigger speed square minus smaller speed square. Okay, now you solve this and you should be able to get the value of V. Okay, when you solve this, you get V is equals to 2.18. First make V square the subject, then square root. So V will come out to be 2.18 meters per second.